Sponges are wonders of the sea. They are filter feeders and are asymmetrical.
So sponges work by pulling water in through the pores and out through the top.
Water.
Look! Mine is glowing!
So you can see when you put the sponge in the water,
It's hot.
the water comes through the pores
Tea?
and into the sponge.
What is that?
Now an actual sponge takes and expels the water through the top.
Can I try?
But I can't do that with the phone
Can I
cup.
try?
Yes.
Echinoderms are marine animals. They have radial symmetry and spiky bodies. Starfish, sea cucumbers, and sea urchins are echinoderms.
Starfish are echinoderms, a type of invertebrate. The way that they eat is really stunning and disgusting. When they eat a bivalve, they pry its shell open with their arms. Then, and this is the gross part, they reach their stomachs into the shell and eat it. Starfish move by using hydraulic. The foot fills with water and stretches forward. Hooks on the leg hold it in that position. The starfish then expels the water, shrinking the foot together and pulling the body forward.
Echinoderms versus sponges. Sponges are asymmetrical. Echinoderms have radial symmetry. Echinoderms have spiky bodies. Sponges have holes in their bodies.
Cnidarians are water-living animals. They have tentacles with special cells called cnidocytes that sting their prey. They have radial symmetry. Jellyfish, anemone, and coral polyps are cnidarian.
Corals are important habitats. They form huge masses called coral reefs, and the reefs provide a shelter for fish, crustaceans, and other sea creatures. Parts of a coral can be represented by using a marshmallow, melted chocolate, sprinkles, and bits of Twizzlers. The marshmallow is the coral's body. The chocolate is the shell they grow. The Twizzlers are its tentacles, and the sprinkles are the bacteria that keep it clean.
A moss has a soft, unsegmented body. They usually have a shell. The main groups of moths are gastropods like snails and slugs. The cephalopods like squids and bivalves like mussels.
Hey, I'm Aaron. Today I will be dissecting mussels. I will do inside and outside of them. So first of all, we are going to do the outside. So the periostracum is like the skin of the mussel, very much like it actually. Its job is to protect the prismatic area, that little white spot right there. It's kind of like the skeleton of a mussel. So the mussel itself is not really a shell. It's actually a squishy little animal in the shell. See, the third part is mother of pearl, which can be found right here, and sometimes inside of it. So now we'll get to the inside. Because the muscles in the mussel that help open and close the shell do not just snap apart when the mussel dies. We will have to cut that mussel. So right here, gonna want to cut it. Without damaging it. There. So this right here is the mussel itself. So let's see what we can find. First of all, we will want to find the mantle. The mantle is like right here and right here. It's basically the outside of the muscle. So, right here is the muscle that helps open and close the shell. So a mussel eats by using siphons. Those little black spots are the siphons. You see, it also helps them inhale and exhale. See, it's kind of like they have two mouths. You see, the really bristly one is the one that inhales, and the tube-like one is the one that exhales. So now we will be finding the gills. The gills, I do believe, are like right here. Let me make sure. Yep. So right here are the gills. Right there that I'm holding. I do believe that it is connected to the mantle, which makes plenty of sense. So now we are going to find the visceral mass. That is where it reproduces. That is where the stomach and intestines and many other parts of its body are. Like right here. Ooh, does it stink? So that dot there is what we want to cut open. So I will gently poke it and then snip. So I did dissect one of its buddies earlier. Long story, we had a minnow in there and we fed it beta pellets. So the other mussel actually inhaled a beta pellet and couldn't get rid of it. So that was the cause of death for one. So right here, I'm just gonna cut the visceral mass open. So as you can see, there's some orange-brown stuff. That, I do believe, is the stomach contents or the contents of the intestines. It is actually extremely interesting. Alright. And that's about it. I'm gonna cut this out and show you some mother of pearl on the inside. So right here is the muscle of pearl. I mean a mother of pearl that is in the mussel's shell. I do believe that you can take it out and kind of make, not exactly melt it down, but mold it down to where you can put it on guitar necks and many other things. So, thanks for watching. This was a very fun experiment, and I hope I helped you. Bye.
Squid camouflage to make them look like rocks to catch their prey, or so they won't be prey.
Okay, so today we're going to be doing an experiment on camouflage. Some animals camouflage to hide themselves from predators, and a lot of them, especially squids, we'll learn about later, are very good at it. Okay, so what we're going to do is we're going to pour your color into the pie pan. Okay, and then you will have 30 seconds to get it out.
35 seconds.
One by one, using a bird beak to get them out one at a time. You have to get the M&Ms out of the Skittles. All right, so. How many?
Right here.
How many?
35. I only had 4 M&Ms left.
How many did you get?
14.
So obviously camouflage matters, and how closely camouflaged something is important.
That's
So-
what I found out.
What do you think happens to a species that sometimes is camouflaged? Like some of its members are camouflaged really well, and some of them aren't.
I died.
Well, which ones died? Let's
The
say,
ones that
let's
don't
say
match.
these are what our predator doesn't want to eat, right? And then we have a lot of M&Ms, right? There are actually more M&Ms than Skittles in here. But if we were going to play this game again, what M&Ms would you go for?
Probably the brown ones. Definitely the brown ones. Blue.
Blue. Kate, what about you? What M&Ms would you go for?
Probably the blue.
Why would you go for the blue ones, Patrick?
Because they probably would be easy.
They are easier to see. Now, if this was a population of critters, guess what? The bird's going to go for the blue ones too. And eventually, there aren't going to be any blue ones. The blue ones wouldn't survive to reproduce, and you would end up with all brown ones. Not that they couldn't be blue ones, and obviously they're still M&Ms, but the blue genes would die out because they get eaten. So Patrick got 3/4. What can you do? Go.
Worms are long, narrow invertebrates that have no limbs.
Worms have little brains. If you look at a worm, you see a bump. This bump is very important. It is called the scutellum. It makes slime. The worms would die without it. They have 10 hearts. On top is the dorsal blood vessel. Worms have a part called the crop. It is like a throat that leads to the gizzard. The gizzard grounds the food. After it is ground, it goes to the intestine. Arthropods are an invertebrate with an exoskeleton. They have a body divided into a simpler thorax and an abdomen. All arthropods have jointed feet. The name of arthropod means jointed foot. Insects, crustaceans, and spiders are all arthropods.
Spiders have 8 legs and insects have 6 legs. They are arthropods.
Crustaceans are arthropods. They have no backbone, but they have an exoskeleton. Shrimp, crabs, and lobsters are all crustaceans.
All right, here we have 3 Play-Doh figures. I made them as close to identical as I can. It's not real close, but good enough, I think. So the idea is to show we have a critter without a skeleton, a critter with an inside skeleton, and a critter with an external skeleton and exoskeleton. All right, and what we're going to do, we're going to have a competition to see which of these can support the most Jenga blocks. All right. So a lot of arthropods, well, all arthropods have a hard exoskeleton, and when they grow, they actually have to shed their exoskeleton and basically grow a new one. And so this is be kind of a demonstration as to how exactly that will work.
Oh, we gotta pop it.
Oh no, don't get water all over me. Well, I'll do just wasting it.
Now, I wanted this to come off in one piece, but it cracked. With a blue crab and most other
Don't pop it.
arthropods, the shell actually, they can wiggle right out of their shell.
Hey.
And you have what basically, can you keep the camera pointed?
Oh yeah, sorry.
You have what basically looks like the critter in a shell. And didn't work with chocolate.
Oh well.
Cat.